Hello and greetings. Today we want to get more familiar with the load cell transmitter. A load cell transmitter is a device to which we connect the load cell, and it gives us a standard analog signal. This standard analog signal can be either 4 to 20 milliamps or 0 to 10 volts. This device has many applications in industry, including the ability to connect the load cell transmitter to a PLC or, for example, to send a command to a drive. Now, when we connect the load cell to the transmitter, the first step is to calibrate the transmitter. Let's go through the calibration steps together. Here we have a current type load cell transmitter. As you can see, it has an adapter here that we've plugged in to provide us with a 24 volt supply. In this section, we've connected the load cell wires. Since our load cell is from the brand SEWHA, the wiring is as follows. Positive excitation is connected to the red wire. Negative excitation is the white wire. Positive signal is the green wire, and negative signal is the blue wire. After connecting the load cell, as you can see, we have an I terminal that gives us the current output, and a GND terminal, which is actually the ground. So the output we get from our transmitter comes from the I and GND terminals. I is positive and GND is negative. We've connected two wires to these terminals and attached them to the corresponding wires of the multimeter. We've set the multimeter to the milliamp mode, and currently the load cell is unloaded with no weight on it. There's a potentiometer here for zero adjustment. We turn this potentiometer until the multimeter shows a value of 4. The load cell we're using here has a capacity of 5 kilograms. This transmitter is analog, so for calibration we need the maximum load. Since it's 5 kilograms, we need a 5 kilogram weight. I place a 3 kilogram and a 2 kilogram weight, totaling 5 kilograms, on the load cell. Now, at this stage, we need to turn the span potentiometer until the multimeter shows 20 milliamps. So with no load, it shows 4, and at full load, it shows 20. For example, if I put a 2 kilogram weight on it, it shows 10, which means the scaling works linearly. This is essentially the calibration of the load cell transmitter. As we mentioned, one of the applications of the load cell transmitter is connecting it to a drive, and we can use this device for filling machines. When the load cell is unloaded, the inverter operates at its maximum frequency. When weight is placed on the load cell, the frequency gradually starts to decrease until the load on the load cell reaches its maximum, at which point the inverter frequency becomes 0. This is widely used in filling machines. Let's test this together. We've calibrated the transmitter, and as you can see, we've connected the transmitter's I to the drive's I2 and the transmitter's GND to the drive's CM. The settings we need to adjust on the drive are shown in the table. We need to change these parameters so that the drive receives the frequency through the analog input. Another important point to consider is that when the transmitter shows 4 milliamps, the drive frequency should be 50 Hz. And when the transmitter output is 20 milliamps, the drive frequency should be 0. As you can see, the load cell is currently unloaded. The transmitter is showing 4 milliamps and the drive frequency is 50 Hz. If I apply some force to the load cell, you can see the frequency changes. Now, if I place the full load, which is 5 kilograms, on the load cell, we see that the drive frequency has dropped to 0.